Hey everyone, and welcome back. Before you watch this walkthrough, make sure that you pause the video and try the problem yourself. Even a partial attempt will make the explanation that much more useful. These videos are meant to support your problem-solving process, not replace it. Across a lot of my practice problems, I highlight different aspects of how to approach, break down, and reason through problems. So you're going to get the best benefit by watching multiple walkthroughs rather than treating any single one of my videos as a template that you can copy. With that, let's get started. Today's practice problem is going to focus on binary searching through a list of numbers. So we are going to implement a binary search on a sorted array of integers where we can actually trace the midpoints being printed at each of the iterations. So I've got two different versions here with two different outputs. Here we've got input 1, 5, 7, 9, 11, 22 with the value that we're looking for being 6. We should not find it. It's not in the array. We can trace through our outputs coming out right here, not finding the value of 6. That's why there's a -1. And over here on this side, we have a similar array, only now we're going to look for the value 11. And when we look for the value 11, we find output very similar with 7 and 11. But then at this point, we can stop, and our index was found at position 4. Given this video follows my linear search video, I decided to sort of pre-fill some code in here to get us started. So I've already created my integer array. I've hard-coded it to match the one from the problem space. I've got my target value, and I've got the print method that we saw previously, so that when I go ahead and run my code, which I will do for you right away, javac main, oops, wrong main. There we go. And we run it after compilation. We will just get that printing out. Then I've gone ahead and already written just the method header for our binary search, taking in our array, taking in our target value, and understanding that we want an index to come out, where if it's never found, we're going to return -1. Otherwise, we're returning the found position. Make this a little bit bigger. Now, with that information, let's try and figure out how we actually do our binary search. Now, what we're going to do is similar to what you would do in a phone book, which is to say we're going to not start at the beginning, but rather start in the middle, because we know our data is ordered. We can start in the middle and then determine based on our middle value if we should be looking on the left side or the right side of our middle value. Or if we're really lucky, we found it on our middle value as well. So for example, we would go ahead and cut this array in half, recognizing that we have 6 elements here. Position 0, 1, 2, 3, 4, 5. What we typically end up doing is when we have an even number of elements, we end up picking the lower of the 2 middle values. So we go to the left, and we will do deterministic math in just a second to get that value. If instead we had an odd number of indices, it'd be very simple to just grab that middle index. Now what we do is we compare our target to that calculated midpoint, and we would recognize in this scenario that 6 is less than 7, which now means we get to update our range that we're searching through. Previously, we searched between our 0th position and our indexed 5th position. Now we'll just search on this side of our array, because we know with full 100% confidence that 6 will not be on this side of 7. So now we can just look at these two values. Same thing, we split our array in half. We take the lower value, it's a 1. We recognize that 6 is going to be greater than 1. So now this is our subarray, just that one number. We do our same calculation and find the midpoint being the value 5. We know 6 is larger. We go ahead and try to do that one more time, and we will have to stop because we don't find a valid array in this space between 5 and 7. That's how we know that 6 doesn't exist. If instead we did this with 11, same thing, we'd cut our array in half and we would start with 7 and know that 11 is greater than 7. So now we look at this subarray. We'd cut this in half, we'd find 11 in the center, and we found our value. So we can stop and we would return the position being position 4. So how do we actually go about writing this in code? Well, like I mentioned, we're basically keeping track of little mini arrays within our larger array. And in order to do that, we need some indices or positions that we can sort of keep track of as we go. So what we'll need is a way to keep track of the lowest position in our little mini array, the highest position in our mini array, and the midpoint in our mini array. So these are going to be 3 integer values. Low will start at 0. High starts at our nums.length minus 1. And our midpoint I'll calculate in just a second, but it will be in the middle. Now what we're going to do is we're going to, while something is true, I guess what we'll write is while we haven't found the target or the target doesn't exist, so in either scenario, what are we going to do? Well, we're going to get our midpoint based on low and high. And specifically, we're going to use integer division to do it so that we can always make sure that we're rounding down. So since everything's already in integers, it's just very natural for us to do integer division. Once we've gotten our midpoint, we have 3 different possible scenarios that come from this midpoint. The first being that our target value is at our midpoint, which would be amazing. That means we're done. We found our found position at that midpoint position. That'd be very helpful. The next possible scenario is that our target is less than our midpoint. If that's the case, then we understand that that means that we don't need to look at anything on the right side of our array anymore. Everything to the right of our midpoint is definitely too big, since our midpoint was too big. So this means that our high value can become our midpoint minus 1, since we're going to be able to now search between low and our midpoint minus 1. Our last possible scenario would be an else, or the target being greater than the midpoint, which tells us that everything to the left of the midpoint is going to be too small. And since everything to the left of the midpoint is too small, we're going to need to move our lowest value up. So our low needs to become our midpoint plus 1. And we can keep doing this, moving our high and low, moving around our mini arrays, checking that midpoint until either we find the value and our found position changes, or we don't find it. And somehow we need a way to sort of say it doesn't exist. Now, our low should always be a smaller value than our high. And what we actually find happen if you track these numbers is what you'll see is the case in which our high and low no longer make logical sense. So our low is now bigger than our high. We now know that the value that we're looking for, that target value, doesn't actually exist anywhere in our array. And so that's one of our conditions of our while loop. So the first condition is while our position is less than 0. So while we still haven't found it, let's keep going. And if we do find it, we can break out. The other scenario that we want to look at, while low is less than or equal to high, because as soon as that no longer logically makes sense, that means we've looked at every single element that made sense and it wasn't in there. So that is our we never actually found it case. So now we have our while loop properly defined, and we can take each of those comments that we outlined below and actually appropriately apply our situations. So the first thing is getting our midpoint based on low and high using integer division. So this is where we're going to take our high and add it to our low and divide by 2. So now if we look back here, we'll see that that would be 0 plus 5. Divided by 2 is 2.5, but we're doing integer division, so we just get 2. So we end up with position 0, 1, 2. So we're going to end up comparing 7 to, in this case, 11. So we can see right away that that is going to work as we expect it to. Now we can go and, if we want to follow along with this, actually print out that tracing of the midpoints. So we can say now, array at position mid is, that's how I did it, yep, and then we'll go ahead and put the actual value that is in that spot. So there we go. That will allow us to now at least trace as we go, as we're expected to do. Now it says, let's figure out if the target is at the midpoint. So if our target value is equal to whatever is at the midpoint, then we did it. We're totally done, right? Found position is going to be equal to that mid value. And now when we leave our if else conditional and come back up to the top, found position is no longer less than 0. It will either be equal to or greater than 0, and our loop will break out. Our next condition, like we said, was going to be that the target value is less than whatever's in our nums at midpoint. And what did we say we'd do in this scenario? Let me just pick this up, put it over here. There we go. And grab this. We said we're going to change our high value because we know we need to start searching between low and our midpoint. So high can become our midpoint minus 1. In our final scenario, we have our else, and the else is when our target value is greater than our midpoint. And that means we need to search between midpoint and high. So we're going to update our low pointer. Here we go. And we can change low to be equal to mid plus 1. This is now going to continue to go until either we find it and found position gets larger than or equal to 0, or our high and low cross points. At the very end of running this, we are told to take this index and print it out right here, index of whatever with the colon. Let's go ahead and add that right here. We can say index of, let's do this with a printf again, percent %d for our target value, and then we can put our %d for our index right there with our new line character, just in case we want that as well. So we can do our target and our index. Okay, let's test this code and see if we've got it right. We'll run it. And we can see that we have exactly what we expected when we're looking for a target value of 11. We get 7, 11 in 2 and 4 with our index. 7, 11, 2, and 4 with our index. We can also confirm this with 6 right over here. So we change this. We'll go ahead and recompile and rerun. And we'll see we get position checking of 2, 0, and 1. So those are our midpoint checks. So really common exam question is to get something like an array and a target value and be asked how many comparisons are actually going to happen. How many midpoints do we end up checking? And we can see right here how many midpoints we ended up checking based on those input values. And based on the target of 11, how many midpoint values we check there as well. So tracing through it can be really helpful. If you're still struggling a little bit with this and understanding what's going on, you can also print out your low and mid values as a way to understand a bit better. So let me just update my print statement here so that it reflects that. We can print out our low value. We can print out our high value. And, oops, that's supposed to be a percent, sorry. And we can print out the mid index value right there. And we can even print out the mid value, meaning I'll do it like this, nums at %d, and put in whatever is there. So with all that, I've got a whole bunch of parameters to fill. The first one is low, the next one is high, the next one is mid, the next one is mid, and then the last one is nums at mid. So now this gives us a little bit more information while debugging through our code, just to get a better understanding of what's actually happening here. So the first time we ran this, we checked between 0 and 5 and looked in position nums at 2 and compared that to our value of 6. We found that 6 was smaller than 7, so we can see how our low and high shifted. Our low stayed the same, but our high is now 1 less than our previous mid, and now we have a new mid that we can check against. We can then do it one more time and see once again that our low and high are now the same value. We're checking right here. If you really want to see that while situation play out that I was talking about, that low no longer being less than or equal to high, we can pick this up one more time. We can put it right out here and just determine what our low and high were. I guess those are the only two things that will have up-to-date values when we jump out. So if our found position is less than 0, let's just see that that condition of high and low is being met. So let's recompile. I'll scoop this up and we'll run it. And what we can see is that after checking that final spot 5 for 6 and realizing we had to now look between 5 and 7, our low became 2 and our high became 1. So we can actually see quite clearly that that no longer makes any sense. Low is now higher than the high value, and that's how we broke out of our loop. These are just stuck together because I forgot my, my new line, as I generally do. There we go. And that can allow us to trace through our code a little bit more carefully if we're struggling to understand what the heck is happening here. So yes, we need to have pre-sorted data for this binary search to be effective, but there's a lot of situations in which it is, and it's significantly more efficient than a linear search. And maybe we don't see that right now because we're only looking at very small numbers, but in some of my other videos, I actually run like comparison timer tools where you can really see the timing difference when you start to enter larger data sets. That's it, and now we've solved this problem. Now remember, you won't find my solution posted alongside this video. If you watch the walkthrough without first attempting the problem, stop here, close my solution, and try to write it yourself now. Post-walkthrough practice still counts. If you have questions about this problem or suggestions for future practice videos, please be sure to leave them in the comment section below. Thanks everyone, and I'll see you next time. Bye.